¿Qué pasa, amigos? Today we're back with another physics video. So, this mastery check, getting a lot of questions on it, and I'm too lazy to explain it every time, so I'm gonna be recording it once and posting it on YouTube. Ta-da, here's the question. And I don't even know if my explanation is right, but it works, so let's go. So, what is the magnitude of a horizontal and vertical displacements of the center of mass of the two mass system shown above if the larger mass moves d equals 1.8 meters parallel to the ramp? So it depending on the question, it's gonna be like different side, but regardless, both of the equations work for this. So we're gonna start off by drawing the two and just assuming each of their center of masses is a particle. So let's just draw triangle, particle 6 kilogram right here, and particle 7 kilogram right here. Okay, now, so it's asking for the bigger one to move 1.8 meters parallel to the ramp. It can move in either direction, so let's just assume that it moves down. So it goes from here to here, so that's D. And the 6 kilogram mass is going to move up because they're attached to a string. So let's just say this is also D. So there are two different angles for this question. So this angle, let's call it theta. And this angle, let's call it, forgot the name of this thing. Let's search it up real quick. Angle sign for math. Well, apparently theta is pretty common, so let's just call this theta 2. Okay, so let's call this length d, and let's call this a right triangle. So the distance it moves in the horizontal direction is x. Let's just call it this x. The delta x is going to be positive for this one because it's moving up the ramp. So we can say that cosine of theta is equal to d over x. I mean, x over d. So x is going to be d cosine theta because we can multiply the d over. Same thing for this one. There's a right triangle and this is d, so we can find the x for the second mass. And it's also going to be d cosine theta. So now that we know these two values, we can just um, use the formula. So the formula that was taught is total mass times x center of mass is going to be equal to the sum of mass 1, particle 1 from I equals 1 to n. Okay, well, we only have two particles here, so we can change this formula to be m1 x1 plus m2 x2. Since both of them are changing, the delta x is positive for both of them, we can just plug it in. So d cosine theta, and the mass is just going to be m1, plus d cosine, wait, it should be m2. D cosine theta 2 is going to be equal to m x center of mass. So the x center of mass is going to be equal to the division of those. I should have drawn the parentheses earlier. All over m1 plus m2. And that's the change in x center of mass, absolute value, which is what's given in this problem. Now let's find the vertical displacement. So this one's a little different because the triangles, this mass is actually going up. Hey, oh my gosh. Okay, bro, work. Oh my gosh. technical difficulties. I'm too lazy to edit this. Frick, dude. Jupiter. Ah! Yeah, you guys should just skip past this part, to be honest. Oh my gosh, dude. Okay, so, oh, what the frick? Okay, so this mass is gonna be going up, so the delta y is gonna be positive. What the frick is going on, dude? I didn't do anything. Okay, these are all different questions. I delta y is gonna be positive for this one, but on this one where it's weird angle, it's gonna be negative delta y because it's going down the ramp this way. This one's going up the ramp. So that means um we want to find delta y, that's gonna be sine a d sine theta, and this one's gonna be negative d sine theta 2. So we just plug that back into the equation, move this over. Whoop. It's gonna be equal to d sine theta m1 plus negative d sine theta m2 all over m1 plus m2. But do be careful because sometimes the negative d sine theta depends on which mass moved. You guys should be able to figure that out on your own. I don't think it really matters because asking for the absolute value change, but yeah, that's pretty much it, guys. See you.